All right, so this is the screencast showing the answers to question on the quiz number 1 here. We have monochromatic coherent light coming in from the left, and it's going to hit 2 openings. And the distance between the openings is 0.3 millimeters, so 0.00003 meters. And that then creates lights and dark spots over here. So we're used to double slit, so we understand the equation we're going to be using. And the first question asks, a series of fringes, they mean the dark and light spots due to constructive and destructive appearance. Explain how the bright fringe is formed. So the bright fringe will be formed here because there's 2 path lengths. So you should definitely first mention there's a path length from one opening and a path length from the other opening. So you have it very clear to the reader that you understand that there were 2 different beams of light coming from each opening that are then going to superimpose on each other. So superposition from each slit or interference from each of them arriving at the screen at that point. And then the path length, one is slightly longer than the other, you should say. And the one that is slightly longer from the slit that's lower down is slightly longer than the path from the slit that's higher up. And if it's going to be bright, it's going to be exactly an integer number of wavelengths, or exactly a phase shifted by 2 pi, multiples of 2 pi. Something about an entire wavelength being delta L, or multiples of an entire wavelength being delta L for it to be a bright interference pattern. So those are your three marks, and that it's going to be constructive interference is the third one. And the semicolon at each one says where each mark is. So then the mention of constructive interference is why it's bright. To calculate D, the first thing is to recognize that dark and bright, the distance between a dark and a bright is half of S. So you're going to take that and multiply by 2 in order to get S. So they said 3.5 millimeters. So you multiply by 2 and you get 7 millimeters. And then you just plug and chug for D here. Make sure that you convert your nanometers and your other things like that. Make sure that you canceled everything correctly by having meters, meters, and meters. And you should get a D of 4.77. Finally, outline why the beam had to be coherent. So 2 points. 1 point was simply to have the idea of coherence. So Ian helped us out with that. That just simply means that there's a phase there's a phase relationship, that they're all in phase. It means that they're coherent. And then finally, that since they are coherent, then in order for there to be a set phase shift between one and the other, then that initial coherence needs to be true, so that then you have a predictable phase relationship where the 2 superimpose. Okay, so that creates the pattern due to the constructive and destructive. Finally, explain 2 changes that could be made using the separation if we were to have the fringe separation get smaller. So in other words, how can we make S get smaller? So if we look here, how do we get S be smaller? So lambda, the wavelength, could be smaller. Here, the distance between the 2 openings could be larger. So the distance between the 2 openings, D, gets larger. That makes S smaller. Or if lambda gets smaller, S gets smaller. I suppose you could say if D gets smaller, S gets smaller. So any of those, but explained according to this equation, where you're explaining the relationship algebraically, is typically what they're after on that question. So that's the first one from the quiz. There you go.